We're live. Time to figure some things out, I suppose. This hyperpram stuff is bothering me, you know? Like, I'm basically, at this point, I'm trying to talk myself out of using Gaussian processes at all. But I think you probably want to use Gaussian processes. You probably do want to use them. I mean, it's just so sketchy. Alright. Let's see if I can at least figure some stuff. What's going on here? Right, wrong branch. Okay. Oops. That's, yeah. All right, it's not this one anymore. It's how did meeting go? Meeting went very well. A lot of stuff today. RMA'd one of the servers, had a good meeting, potential client meeting. And what else? Oh, I got a good chunk of my gym equipment delivered, like 7, 8, 900 pounds of equipment. I don't know, a lot of equipment. So that's nice. Let me see. I still don't have my rack. But yeah, this is pretty nice. Oops, come on, camera. All right, you can't really see how nice these plates are, but whatever. I'm very happy with them. Welcome. Demo HTML. Okay, so this is where we were last time, right? If I do this, I basically just need to figure out what the heck is going on with the these Gaussian processes in here. Okay, plus 38, that's obscene. About 1. How about 1? No, not 1. Then like 2 or 3 maybe? I don't know what it is in norm space. Hey, welcome. I guess I should briefly say what it is I'm trying to do here, huh? Let me test 1 or 2 more things and I'll give a little explanation. Because this is something that I think is going to be very, very important. Seems like it's right here, this spike, right? Okay, it's exponential, so you can't go much past 5. It goes insane. You can actually see the score reversion to me in here. So there you go. So that is an interesting result. Okay, I suppose I should explain what it is that's going on here. So I'm attempting to make a ludicrously good hyperparameter sweep algorithm for reinforcement learning because I think that this is going to be the single largest thing I can do to improve RL is just make solid, consistent, trustable hyperparam sweeps. It should speed up all experiments by a factor of 2 to 10, just across the board in the field. And what I'm doing at the moment here is the way the algorithm works. It's based on random samples. They're not uniform random samples, they're carefully chosen. But essentially, the algorithm is going to propose like several thousand points. And then you use a learned model, a Gaussian process, to rank which of these points you should consider. But the Gaussian process, which is very commonly used for this approach, for this area, it has some weird properties that make it not really usable directly out of the box. So in particular, the way a Gaussian process works, it's kind of like a fuzzy nearest neighbor thing, where if you're nearby some points, it estimates based on those points. But if you're far away from points, it reverts to a mean. It usually reverts to 0. So what people do is they try to like put their data into a standard normal so it like reverts to a reasonable mean. But you can't really just do that. It doesn't, like, that doesn't give you what you want. So for instance here, like it's saying that the average value that it should revert to is something over here instead of like fitting a line or doing something reasonable. Yeah, so this is just not great. And then the other thing I figured out recently was that cost before, if you don't set it up correctly, cost reverts to 0 as well. So like it will systematically say that your experiments are going to be cheaper than they actually are. So there's a bunch of weird math and biases that I'm trying to fix here. What are you experimenting on? Is this one of the experiments from your iceberg video? Do I cover hyperparam sweeps in there? I don't know if I cover it directly, but it's very clearly related. So in the iceberg video, I talk about how we want to run tens of thousands, hundreds of thousands of experiments. And we have all the M's now to do that. Everything is fast. But what this is for, this is going to increase the speed at which we can run those experiments, but also it's going to give us a lot more confidence in their outcomes. Cost is much simpler than epochs. It's just the time and seconds that your experiment takes to run. So that's what you care about, right? You care about how long it takes to run your code. There were ways to automate hyperparameter. Yeah, that's what we're working on. This is the algorithm. Only have experience with CNNs? I mean, I have, did you see my quick start guide? If you're looking to pick up some RL, we've got a nice guide for people looking to get involved with this. Here. That's a quick start guide. It's a very practical guide, minimal math, minimal background papers, gives you some perspective. Pretty short read. Mm-hmm. Well, I don't really know what I'm doing here half the time. The thing is, I kind of don't have to. The only thing that is required for me to have confidence in my work is for me to know I'm the most qualified person to do it. Right? You don't have to know what you're doing all the time if nobody in their right mind would reasonably know what they're doing with this mess. It's like I'm doing it because I figure I'm probably the most qualified to figure it out. And if I do figure it out, it'll be really good. I don't know, there are probably some like niche math people that also would do a pretty fine job of this because I'm a little out of my area with the statistical modeling here. But practically, I think I'll nail it pretty well. Because like the thing that's weird here, right? It doesn't take too much math to see this. What's happening is you get far away from these points, the predictions get pulled over to here. Any specific algorithm you're optimizing hyperparameters with. So what I'm trying to fix, this is a new algorithm. It's based on ImbueAI's CARBS algorithm, but with heavy mathematical and engineering changes. You'll get to the point where you know what you're doing just when you're writing normal code. Actually, writing normal code is like, env code especially, like writing high perf sims is super chill for me now. Said you're one of the few people doing stuff. Well, AI has become a pretty lucrative career to say the least. So a lot of people are just, they're working behind closed doors at companies now, which I think is unfortunate. We should have more people doing their own stuff in the open. But LLMs are particularly annoying because they've made AI very capital intensive. So it's really hard to do stuff in the open with like the amount of capital that you need behind these stupid things. Which is why I like RL. I don't have to deal with that mess. I'll let the thousands of people who are already trying to do that on that train deal with that. I'll fix RL. I got this, guys. What if we do this? Okay. So doing this, normalize max cost, we leave this, right? And where's score? Doing some research on cancer, whole slide images, using RL for determining. PufferLib for image recognition. Interesting. Why is that an RL problem instead of just a classification problem? Like why, what's the portion that requires a reward function? The existence of cancer as a problem for humanity pisses me off. Like, by now, you should be able to buy a $2,000 scanning machine that, like, sits in your shower and just scans you in the morning and says, no cancer detected, or whatever. Why haven't we fixed this shit? I mean, okay, is there an easier way of doing that other than turning your shower into an MRI? I mean, there'd be demand for that, for sure. Sell a ton of those. Quality of images are high, it gets expensive to train. We do inference on images. Haven't found an algorithm that can train. Isn't it local though? Can't you train on patches? I mean, like, what's the resolution of the actual cell pictures? Pretty much everyone just trains on patches. Single cell RNA sequencing. Both these, and we can make a reward function that determines what the... Is this not a labeled data set though? How do you have a reward function for something like this? Do you have a sim somehow? I don't see how you have a reward function but don't have labeled data. I haven't been in Vision in a very long time, but I would think some sort of model that you can do patch-based and then just like scale it up by feeding in more patches to the same classification output. Oh, so you don't just have a data set of these cells are cancer, like these images of these cells are cancer and these ones aren't. I mean, the thing is that data exists, right? Like that data exists, hospitals have it, and actually like they package it together sometimes and they have it and they keep it proprietary. Like you should just if I were trying to solve this problem, I would just like go after the people preventing you from using the data for research and just like make their lives miserable via whatever actions I could, legal, what, however the hell you can, like try to like get that data out into public. That would be what I do if I really wanted to like make push this research forward. It's really tough without data there. Cell labeling through inference of what they produce. Can tell it's pretty tough to get. Well, the data exists, right? For like, doesn't it like hospitals have it, right? Just like over time from all the patient data. Like the patient data exists, doesn't it? It's just not anywhere you can get it easily. Yeah, screw that though. Like, oh no, privacy. You can't get some pictures of my cells. Like, you're killing everyone with cancer with these regulations. Like we'd have like if you just gave us data, it would be solved, right? It's an ML problem. Data in, solution out. Hard to get labels of what each cell is. I see. Hmm. Well, that's the main reason I don't do stuff in medicals, the regulation. Because like frankly, a lot of these problems, it's like way more practical to try to like axe the regulations around them holding you back than trying to get really clever with the algorithms. That's the annoying part, right? You'll do way more for cancer research in a day by like getting an exception added to these things that lets you do the research than you will ever by coming up with clever algorithms. That's the unfortunate bit of it. We take a whole systems approach here at Puffer. The problem may be attacked in any way possible. I don't know. If I really like, if this were the problem that I were trying to solve at the moment, I would try to go get like, a few like really good medical people, like well-respected medical people in this space, and like take them to Washington. And with the new administration that's shaking up a whole bunch of stuff very quickly, see if you can get this to be one of the things that gets cut. That way, or at least there's an exception added somehow. Might be better to beg for my grant funding. That's rough. But frankly, like, now is a very good time to try to do crazy stuff like this. I don't really need to in my space because my stuff isn't impacted by regulation so much. But in medical space, a lot of the research held back, right? Hard problem. That's also legitimate, right? Maybe there are maybe there are actually technical things that can be done, but it's a heck of a lot easier when you have all the data. Yeah, it's a good quick read and suggested. I'm going to focus on this for a little bit. So, I mean, anything outside the support is getting pulled over to here and to like here, right? This is where it should be getting pulled. Oh no, wait, hold on, I'm stupid. Very, very, very stupid. See, this is better. Actually, we'll do contrast like this. Way better. You see this? This is what happens when you pull it up this way. Now we're pulling it down to here. All right, so everything that's not confident gets pulled down to here. See that there are still good points, right, where things are confident. And now we get to look at the kernels. Here, this is just the Matern kernel with the default length scale. We add in the linear kernel because linear kernel should be useful. The hell? How does this make any bloody sense? Somebody please tell me. It's not pulling them down to here anymore, right? What is this? These are so janky, man. I need that frickin' linear kernel, too. From my tests, I know I need that linear kernel. Is it, I'm gonna do this. It's even worse. I can do this, but I don't think this is a reasonable kernel. I mean, so this is everything getting pulled over here. In what space is the matern kernel operating? Hang on. Well, the thing is, like, we know that this is bullets, right? Like, this whole top section doesn't exist. So this is all bullshit. Hang on, maybe if I just do... I mean, it's like... It's still useless. This is not good, this data. It's so obnoxious because... With the matern kernel, it was kind of reasonable, right? Starting to look kind of reasonable. We could do a simpler algorithm. What's up with my camera? Like, unfocused for some reason. There we go. Let me think about this Gaussian process. I'm wondering if there's any reason that I wouldn't just be able to replace this Gaussian process. Well, you're not going to have a linear fit. That's the issue. Right? Damn it. It's freaking linear kernel. Length scale. What about just an RBF? Wish DeepSeek would add Claude-like artifacts. I don't know, I haven't used the model. That's better than before, isn't it? Hang on, that actually looks good. There are a couple overestimated points. That's crazy, not... I mean, I would want to go find one, like, I could try it, I guess, but all these models are incremental improvements on each other. Like, the capabilities are not vastly different. And most of my work, I'm not here, like, typing stuff into a language model. I occasionally use them for, like, background stuff, but, like, I'm not writing my code with a language model. I have single line autocomplete in my editor. That's all I use for that. I mostly use these things for background material. I mean, I have some charts now, as you can see here, but for the most part, I'm not doing a ton of visualization work with these. I've got other stuff for that. Okay, so you can kind of see this front where it's getting dragged down this way. These seem very optimistic to me, these points. Maybe there is something to the return. That's Gaussian. And then this is Matern. Okay, yeah, so Matern here is a lot more conservative. You can very clearly see the front it's being dragged to. Cost goes this way when it's uncertain. Score goes this way. Hey, how's it going? I mean, what do we think about this? It's like, this could be a decent... We might be ready to run some experiments with this. Even just to see what it does. How's it going? Almost out of Blender, Hal? I guess you get to pick up some animation stuff. And something. I'm still in Gaussian process hell. Your renderer got a lot fancier, I saw. I went to look at the code to give somebody a 3D example. It's like, okay, there's some stuff in here. All the lights. Oh. Um, well, shit. Hey guys, I got perfect hyperparam sweep data on this synthetic test. It did, let's see, 47 it predicted, got 46, did one at 39, 578, very accurate on the predictions. This, 92, 93. Cost a little bit more here, 147. This looks good. Guess let's rerun it with the linear kernel just to double check, but I think the linear kernel sucks because it biases shit. So I think we're just going to keep the matern kernel. Kind of awkward. I think we just hit another milestone on this. $6,800. Very nice. Keep on that. This is about the same. It's a little farther out, actually. Okay. Maybe linear kernel, not terrible. There's a lot of new science stuff to try to work on as well, Spencer. Man, there's so much to do. I gotta figure out where the contact at that robotics company went. 'Cause I'm trying to get something with them. We've got 3 potentials, like 3 good leads at the moment on new contracts potentially. I'm hoping we at least get one of them. That'd be good. Science soon. To be fair, the science is still a bunch of engineering. Because that's generally how I do stuff. But it's more science. Okay, so that's a perfect run, right? We're in agreement that that is a perfect run. What happens when we do this percentile test, right? Science side soon. cost. Okay, so cost model is spot on. Score model is overly optimistic. Man, the score model is off. Engines still need to be written in C. Oh yeah. Let me go check for them because I owe them work. Well, it's a pre-collab, but still. You tired. I owe a ton of people work on stuff. It's just a lot of work. Mid-March it should be done and have more. Okay. They always take a while to get around to stuff, so probably. What transfer am I using right now? What transform? I am using, not that. This transform. This actually should... I thought this one should work. Let me try this without the linear kernel real quick. And for reference here, even though it looks like this is a very good result, this is a percentile task. So the error tolerance is very low on this. Construction site, more time. Is that any better? Well, it is kind of better in the sense that it didn't freaking go to crazy. Yeah, you see, it didn't go to crazy cost here. So what did this get us? This got us, we got 996 at 56, and then 997 at 67. So these 2 points, and then these are all three. So there's really only one bad sample here, right? Hold on. Okay, so this one was a miss, 32. Still a Pareto point. Neocarbs, man, I don't know. This is hard. Alright, this is hard. Looks better without the linear kernel to me. Let's go test the line one. Oh, the other one was what was it? It was this. Nothing. Is there good docs on? Yes, but the docs for Isaac Gym are part of the Isaac Gym download. So they give you the HTML files, and then you run your web. You run a local web server to be able to read the docs. It's kind of funny. They just like hand you the HTML, and you just run it. You're tired. You are a sleep-deprived high school student. See, I've missed like an hour of sleep 2 days in a row, and I'm freaking exhausted, alright? In my sleep. Missing sleep. I generally think that after the point, probably somewhere in your early 20s is a good time to stop doing that. Doesn't mean don't work hard. You can work at least, you can work 70 to 80 hours a week and still get a bit of exercise and still get sleep. Just can't do much else. See you later. Yep. See you, Spencer. That's not bad. That's not bad at all. Okay, so with good data, this model seems like a clear win. Now, what does this model do when you don't have good data? So we're going to set this to like 10. And then the number of runs will be 20. We'll start with the linear. What? Oh, it's just the God algorithm. I get it. Yeah, totally. No problem at all. It's just the God algorithm. That makes perfect sense. Okay. No big deal, guys. We just discovered the God algorithm. Don't mind me, ho hum ho hum. We'll see if it works on real problems. But this kind of looks like the God algorithm. I'm just saying. Just turned 19. Congrats. Made it another year. Yeah. I mean, 19 was that freshman or sophomore year undergrad? Yeah, I worked like probably 90-hour weeks most of my freshman year. And probably almost that my sophomore year. Um, didn't get any exercise. I probably could have gotten more sleep, but I was doing like 80, 90-hour weeks and then screwing around a bunch the rest of the time, going to dumb parties and stuff. So, which to be fair, I think is important. I don't know what your background is, but I basically had like no fun doing dumb shit. I had like no opportunity to have fun doing dumb shit before that in my life. So I kind of needed to get it out of my system for a few years in undergrad. I think that's legitimate, you know? So it's like point. Yeah, this is about right. I want to run an extra few points just to see what it does. Just working two different fields. Yeah, it'll do that. The best anxiety killer is deadlifting. I highly suggest this. You gotta be trolling, right? Did I screw up? Am I somehow using the test data? I mean, I'm seeing these predictions, and they're pretty good. I'd prefer if they were overestimates of cost. But the score underestimates as well, so it's not bad. Yeah, okay. God algorithm. And then the percentile task should be hard, right? Just bought some equipment. I forget if you're the one I showed this to already, but is this gonna show? Actually, let me just send this to myself real quick. Can you message yourself on Discord? You can't, can you? And put it in Gen. My rack isn't here yet, but I got my barbell and my plates. Very happy about these. Yeah, I got nice plates. They are these them? Yeah, these are them. They're nice. I just got what did I get? 25s and 45s. Cause like I don't know who uses the other ones. They're very nice. Oh, are these them? Black? Yeah, I got not these ones. I got the fringed ones. Yeah, these ones. These ones are cool. I don't need the 35s. But yeah, they're nice. I'm very happy with them. I haven't tried dropping them yet. We'll see, but I'm sure that they will hold up very nicely. Okay, so this is the hard task here. So we say 859, we get this. We say this and this. 90. Okay, we're underestimating on score. This is actually very, very close. These are very, very close. In fact, I think that the bad ones here are just, yeah, some of these are random. Where did the bad ones come from, the high-cost bad ones? There's one at like 42, maybe? Oh, this is 87. This is the first sample. Why does it do this then? That's kind of weird. And then there's one at 60 something that's bad. 63? No, like 60. Oh, this is a random sample. Yeah, it's blue. Okay, this is a random sample. And then this one here Okay, so this one was only possible because we got an unlucky random sample this run. We know how to fix that portion of the algorithm anyways. That's very easy for us to fix. Let me add a to-do. Okay, so now this is maybe better. Much better. Look at this. So this is very easy to model, but in a variety of different spaces, this is done like perfect. So I'm gonna make a commit right now. Before I mess anything up. We're gonna clean up the code. We're gonna add a few small tweaks with clipping and stuff. And then we'll figure out what environments, what settings and environments and such to test this on. This is kind of crazy. Screwed up one thing for somebody, that's my bad. Okay, so yeah, for folks watching, I just had to take care of one quick thing. I think we've really gotten the algorithm right here. So now the only question is going to be cleaning it up, doing some tests. Let's just start on that. I'm gonna at least go get myself a drink first. I'll take 2 minutes. We'll start on this. I think this is going to be really good. I think we're going to end up with a really small piece of code that's going to be able to handle all this and fix up all the variable names. It's going to be really easy to follow. And yeah, you'll be able to see what I hope will be the algorithm for hyperparameter tuning, at least in RL, being finished live. Be right back. So, while I clear my head real quick and get ready for this, this is now an unboxing stream. Let's see. I'd say a 30% chance this is a completely stupid purchase. 20% chance it's amazing, and the rest of it chance that it's just like kind of okay, but doesn't magically solve all my problems. Got one of these overpriced sleep watch thing recommended by Brian Johnson. Comes with snake oil and Kool-Aid. Oops. Off to a good start, shitty packaging. Watch band. Okay, exceptionally shitty packaging. What the hell? Yeah. How are you supposed to adjust this thing? Thing like defies common sense. Okay, there it goes. It's just not. Okay, so this is always on. Charge before use. And presumably this is charger with the world's cheapest tiny cable. Cool. And this just goes in here. This or something. I think it goes over the top. Yeah. Alright, so charges this way. Not particularly easy to charge, but this is all it is. It's a band that you wear this way, question mark. And this is watch band. Oh, it does have a buckle. Why was that so tight? And why is it not secured whatsoever? Alright, whatever. We will figure that out later. Overpriced watch. We'll see if it actually does anything. Whoop did he do? See? We'll see what I did there. Whoop did he do? Haha. To be fair, the watch is free. It just comes with a very expensive subscription. Okay, we do a little hyperparameter stuff, and then I think I gotta help out somebody here, but I want to fix this up real quick because we have crazy algorithm here. That looks. What is the Aura Ring a sleep tracker? I figured it was something more ridiculous because of the number of SF people I've seen posting about him. Do we have conservative cost estimates in anything? We do not have conservative estimates. Perfect. So I think we just get rid of all the conservative estimates. Correct sleep. Yeah, it's not Brian Johnson endorsed though. Speaking of which, I haven't taken my ridiculous quantities of pills. Thank you for reminding me. Oh jeez. This again. Whatever. And then we will fix up. No, these are vitamins and supplements. Caffeine. Not caffeine, it's just a bunch of vitamin supplements. It's just Brian Johnson's like blueprint thing. I don't know. I think they're generally decent. I felt better on them. They're like way overpriced, but for the convenience of having them and having everything be lab tested, it's pretty decent. That's gotta be a Ligma. There's no way. We're gonna get rid of all the stuff that we were trying before that we didn't need. Don't use quantile transform. We don't use this transform. We do need max score. These are hard-coded for now. It's mostly the variable names that suck here. Everything else is fine. At least, like, okay, let's try this. So scores is Y, right? I think I can just do min YT norm like this, right? Torch from NumPy. This is norm. And then cost is going to be X. Well, hold on. It's actually not cost to score like this, so it shouldn't be Y. It should be S or something, right? Let me see, what do they use in the paper? GPY. So they do use Y. Okay. So this is C. Okay, this is already looking more easy to follow. Funny thing about long variable names, they are absolutely terrible for math because it's just there's too much freaking stuff to read. So now this is GP. What up? How's it going? We're solving hyperparam sweeps. Is what we're doing. Log cost standard deviation as what the hell? Do we even use this thing? We do. Big picture for today is looking like I think we found the God algorithm. It's really freaking good on all of our synthetic stuff, unless I made a mistake. And we're going to see if once I clean the code up, inspect it for any possible screw ups, and try it on some real problems, if I have indeed found the God algorithm. Though I am also waiting on some messages from somebody who I might have broken some stuff of theirs, and I need to fix some drivers for them. So we'll see about that. Normalized log cost mean. So this is, what was this? Normalized log cost mean. Okay, so these were the output variables. So this is VP, Y, no, C mean, minus min log C, times am I stupid? This one does each other, right? Am I stupid here? Let me see. See what we did. This wouldn't affect, I don't think this would affect anything. So we're still safe on the algorithm. But I think I did something stupid. I mean, the alternative to this is I could code in perfect silence, making monotonous comments like this constantly. Ah, yes, it is time to revise the code. Are there errors in the code? Ah, yes, I see that there's a bug in the code. I shall fix this bug. What the hell is this? Normalized log costs. Hold on. Transform scores is this, right? And then norm scores, subtract mean divided by standard deviation, right? To add the mean and multiply by the standard deviation. to get transform scores, right? So you subtract so this cancels. You subtract the min, and then you add the min. What? I don't know what the hell I did here. Does this get used? Wait, hold on. Does this get used? It's used by cost mean, which we should use, right? Log cost est. Well, what are you gonna comment in here, man? This is just me screwing up basic transforms. Just take a quick look for somebody at thing. I'm getting and you write comments. I mean, I understand the purpose of comments and how to write comments for the most part, yes. Everyone knows that the real purpose of a comment is that it shows up in a different color in your editor, so it breaks up code because you have a different color. All right, you don't actually read the comments. Oh wait, I do the same stupid thing right here, right? So I just have a redundant transform is all. So this is redundant completely, right? Divides by this, then multiplies by it, and then adds back the yeah, so this is redundant. Okay, so GP log C, get rid of this. And then this is, yeah, literally all redundant. So we don't need GP log C. This is just, this doesn't get us GP log C. This is just GP. Then this is var. We shouldn't even append mean. You just do like this. It's easier. Yeah, this same thing is ridiculous, right? Norm divided by time. So yeah, this is silly. And then we just, oops, VPC, the exp, Pareto, y norm. Backend. What torch did you get? Because we don't do anything fancy. So like, you probably need a newer torch. Do they have this? Is this new on torch 2.6? I don't know when they added this, but make sure you got a new enough version to have it. Because we don't do anything that would make torch backend work. So that shouldn't be, I mean, if you get like a device not recognized from PufferLib, I'll fix that real quick. There shouldn't be anything though. I'd be surprised. unnormalized score mean. So this is GP IT. I'm getting these messages. EP IT norm. IT mean. GPY. And then nearest Pareto YT. Pareto Y. And then what math did you have to go up to? My math sucks. Honestly, like relative to most like good AI people, my math is dog shit. What did I do? I took a decent number of like linear algebra courses over the years. Decent-ish number. I took like some dynamic system stuff that I don't remember at all. I tried to take like one math department course and that was garbage. I took some basic engineering math that I do not remember. I don't know. That's about it. Linear algebra, multivariable calc. I mean, most of it is honestly you just the only math, like the only major math thing, right? Like, yes, to understand neural networks, it's tensor calculus, but it's only differentiation tensor calculus. It's only derivative calculus, and it's the same as single variable calculus, except you swap everything for a matrix, and occasionally you have to transpose one. So it's not that bad. Getting very comfortable working with tensors is not math, it's just engineering. Tensor is not a fancy math object, it's just a multi-dimensional array. And then I probably should have paid more attention to my stats because this would have been easier. But frankly, I just don't touch that much stat stuff anyways. Now, where I did invest a lot of time was in learning how to write better code than other people. That is where I invested a lot of time. So I did a ton of research. Oh, also in getting like a good perspective, like a good scientific perspective, sort of just getting your head on straight on like, you know, how does the field look, what matters in science, what things are likely to push field forward, what things are not likely to push field forward, how to evaluate quality of research, right? Basic, like getting pretty decent at basic science, I would say. That also was some effort. These are things I mean, my playbook, I say, is 80% engineering, 15% science, maybe 5% math. How'd you learn to write better code? By writing a lot of god-awful code. That's about it. Now, stuff could have saved me some time, mind you. Check out PufferLib if you want to see how I'm doing stuff now. But programming is just horribly, horribly taught in high school and college. It's horribly taught. So many people start with Java. Java is a terrible language. Java teaches you negative programming. Then they teach you all these abstractions and design patterns and object-oriented like garbage. And then you eventually run on to the academic counterparts of these, which are the functional programmers who think they're very clever, and it's all a massive waste of time. Torch inductor doesn't support, well, what's torch inductor? We shouldn't be compiling stuff by default. So it should have a backend. What do you think pushes fields? I mean, my iceberg video is kind of how I look at things, right? So it's not like, ooh, look, clever algorithm by other person. I can improve upon clever algorithm and get 5% higher performance. No, I look at reinforcement learning. I say, hey, all the code in this field sucks. None of this stuff is trustworthy. It's also 1,000 times too slow. I notice that you guys have really, really high variance experiments and you're running like 5 of them. I also notice that results on one domain never, ever, ever work in any other domain. And this is like such a commonly known problem that it's a joke among academics. So what is the solution to this problem? You guys need to actually run decent experiments with code bases that don't suck. Why can't you run enough experiments? Well, because your M's are too slow. Why are your M's too slow? Because you didn't bother to actually put in any effort whatsoever into making them fast. Okay, so let's make some fast M's. Boom, now we have fast M's. That wasn't that bad, was it? Okay, cool. So, now the whole rest of your stack makes your M's really slow because you drop performance at every layer. Okay, let's redo that from scratch. Oh, that was only like 2,000 lines of total code to replace tens and tens of thousands of lines of tools and garbage that's been used for the past decade. Okay, cool, that works. Now we can run a lot of experiments, but we're noticing that stuff is really sensitive to hyperparameters. Okay, let's look at some of the good hyperparameter tuning algorithms out there. Okay, carbs is pretty good. I noticed that when we run all these experiments, there are a few places where carbs fails. Let's go look at the carbs code. Oh, that code is really bad. Let's go through the code. I'm finding a bunch of errors here. Let's rewrite this and see if we can really understand how and why hyperparameter tuning works. That's kind of how my monologue goes over the course of like weeks and months and years of research. You see how in there's like there are 0 particularly complex ideas that require a ton of heavy math or anything, right? There's 0 particularly complex ideas there. It's just looking at stuff at a high level and trying to understand the levers that move things around. That's all it is. How should one move up in programming? Build stuff. The only way to get better at writing code is to write code. Specifically, I mean, I'm going to show my own thing here, but if you want to make some puffer M's, right, I review all of them contributed live on stream. And that's a pretty nice way to learn how to write low-level, very, very performant code that doesn't get in its own way with too many clever ideas. Now we have to go over this meticulously and make sure I didn't do any of it wrong. That was super insightful. Gotcha, I want to develop that scope. More about it, just need to finish DiffEQs and discrete class and I'll get in it. Yeah, I mean, I took those. I took those because they were a random requirement. Yeah, I've not done differential equations once in any of my work, but it's fair. I like building stuff, you know? I started out doing more like math stuff, right? More algorithms and math, and it frankly just wasn't very useful for stuff I wanted to do. So like, the more I got into engineering, the more useful it was. So I just kept going. And frankly, like engineering skills exponential. You get exponentially more useful as you get better. Like a team of mediocre engineers can go write 100,000 lines of code to solve a problem, right? Like very often, a really good engineer will either write a few hundred lines of code or like write 0 lines of code and figure out that everything that's being done is completely redundant. So the funny, like, oh, there are no 10x engineers, nobody's 10 times more useful than another programmer. No, people are 1,000 times more useful than another programmer. In fact, it shouldn't be a linear function because a lot of programmers are doing negative work. Internships fall through. Hopefully internships fall through, jeez. Well, we do open source stuff. There will be bounties eventually. They're not going to be internship positions for a while because there's no VC money. So pretty much it's like money in from clients has to go to people working for clients, and that's about it. Hopefully we fix that in the future. But we're definitely happy to see open source stuff. PufferLib, way to write low-level code, mostly coded in Python. So. I mean, this has been my latest thing, right? I'll probably have different opinions a year or two from now, but based on my experience so far, this has been a really fun and a really good way to develop, some low-level skills, to write really performant code, and to kind of see that, like, when you look at a ridiculously convoluted, like, repository in the future, you're no longer going to be, wow, what a good programmer, right? I got to study a lot to understand how all this works. You're going to look at it and go, this is awful. I could do this 1,000 times as fast in a quarter of the code. Right? Where is this thing I'm looking for? Raw scores. This is Y. Max mean standard deviation. Transform scores. 1 minus Y over max score plus EPS. Fine. YT mean, YT standard deviation. And then we have YT norm, which we subtract YT mean, yes. YT standard deviation, good. And then this is going to be normalized scores, which is here. This is YT norm. Yes, this should be fine. I mean, there are a ton of low-level projects you can do. It doesn't have to be PufferMs, right? You can write a ton of different projects, low-level code. But I generally, and you don't even have to write C either. You can write perfectly good Python. It's just that the language kind of pushes you in a direction of writing like overbuilt stuff, whereas C doesn't give you those tools to shoot yourself in the foot with. It gives you other ways to shoot yourself in the foot, but not design-wise. It's very zen. I very much enjoy it. Norm, set data, train, score opt, eval. Perfect. Min max scale here. So we get C, we get log C, min log C, max log C, right? And then we do log cost minus min, divide by this. Then we immediately take this thing and we multiply by this, and then we add the min back. So this is nothing. This norm doesn't exist. I mean, what's it? Is it taught in frickin' Java? Then yeah, probably. I told you, the course that you need that you're missing is 106X. Yeah, right. Well, the course you're missing is 106X. I don't know if there are other universities that have a better one, but Stanford was pretty good. Oh yeah, don't do that shit. Stay away from. Well, if you want to do web dev professionally, then sure. But I don't know. Web dev's kind of gross to me. That's like a whole chunk of engineering where nothing makes sense because people overbuilt stuff. Yeah. But no, I had to do like most of the website, the puffer.ai website. It's a pain in the ass. Electronics is fun. This is so bizarre to me that I did this. Like, how freaking tired was I? How asleep was I to do this, right? Log cost, divide by this, and then multiply by the same term. And then, so this doesn't exist. Normalize max. Do I even use this then? Min log C. I don't even use this. I don't even use this. Oops, is this min norm? Yes, so this is YT norm min. Okay. So this is now done. Sample your suggestions here. Pareto points, stack, sample, lib. Done. Predict scores and costs. YT norm, YT bar, norm var, C, bar. Then we do GPC. It's exp. Because this mess is all redundant, right? Because you divide and then you multiply, you subtract, add, yeah, so it's all redundant. So GPC done. And then normalized. You don't need these. What car path they do? Why haven't I seen this? Oh yeah. I don't know. Carpathy has been doing a lot of like educational stuff lately. He does good stuff in that space. My goal is not to be like educational as a goal. It's educational as a means, right? So like in Puffer, in the Discord and stuff, like yeah, I mentor people who are like willing to contribute libraries so that we can have more people around to push forward all this cool RL research we're doing, right? My primary focus is on cutting edge reinforcement learning, advancing the frontier. So I probably won't do anything similar to that. I made like, I'll make like a quick start guide or something because it's like, hey, you want to contribute? This is where you get started. And then, for every 10 people that say that they want to get started, maybe one person actually, goes and does the work of going through it and then, writing some environments and stuff. But still, we get a few people. Normalize Pareto. Wait, Pareto YT norm. Normalized scores. Where's normalized? That's at the top. YT norm. Pareto C. Cost, yep. And then this is supposed to be cost mean, which is GPC minus Pareto C. Do abs. Then Pareto dist min delta. Set it. Nearest index. It's argmin. Dist to nearest. Well, this doesn't make sense. Hold on. Distance to nearest. Dist to nearest Pareto, and then unnormalized nearest Pareto score. Okay, so we need to have, so there is a reason for this. Dist. This is diff. And we do Pareto dist, 0. This is actually C, diff, Pareto dist. Okay. Okay. Let's go over here. And which of these all do we actually need? Unnormalized score mean. So we've got these. Unnormalized nearest. Unnormalized nearest Pareto score. I'm gonna start writing it out, thinking of doing something in continuous space. Cool. I'm trying to think what are good things in continuous space. Did I already give you wait, I thought, were you one of the people I already gave an idea, gave like somebody a sample idea for? And I'm careful because I give out like lots of project ideas for people, and then I don't know which people actually do them, so I try not to repeat to different people the same idea in case somebody's still doing it, at least for a while. Nope. What's a good continuous test end? like that we don't have. I mean, I can give you stuff that's. The thing is, I'm hesitant to give you stupid fly. I'm hesitant to give you anything that's likely going to require a physics engine. Can you tell me? Yeah, I'm trying to think because I've given out a whole bunch of project ideas lately, and I might be fresh out. I mean, there are a ton of different things that can be done, obviously. These are all discrete. It's freaking like lunar lander. This might be a little bit too much because I like. I mean, if we don't care about the physics of this thing too much, I think there's still a little bit too much annoying math with this, though. Yeah, there's too much annoying math with this. I could simplify it a fair bit, but there'd still be a little bit of annoying math. Let me think what else. I'm trying to think of like projects that would both be good for you to learn and also like genuinely useful for Puffer as well to have. There's stuff that's continuous, but kind of just one step. I want to give you something like good that you'll be happy with, that like will be useful. What's that? Energy plus? You're not seriously recommending I give this to him as like a new thing to, yeah, just go implement all this, right? Stuff in simulation is good though. Let me think. Like in like industry, let me think. The tricky thing is that when you get to high fidelity continuous, that's all complicated robotics stuff. I gotta find low fidelity continuous. I mean, we have a few of these already. I'm trying to think of like what would be a good one, like something that's gonna be fun. Got a couple ideas so far. Let me see. Let me see if there's anything obvious though. Where'd this come from? Was this just a GPT? This is a GPT article, isn't it? This is 100% a shitty GPT article. Yeah, this is like. No. Literally, the numbers aren't even in order. Isn't that insane? I was thinking about Mario, but it has a discrete action space. Yeah, look, 5, 4, 3, 2, 1, 5. Oh, actually, I guess it's 3 different. But then they're completely out of order as well. Yeah, so this is moronic. I'm just looking for like what would be a useful, pretty simple continuous end for Rashab to implement. That would be like, what would be something that's pretty simple to implement that'd be useful for Puffer. Ideally doesn't require box 2D. It's like simple enough, but will still be useful. I mean, here, let me try. I have an idea. There's something pretty basic, but it should be enough for continuous. Yeah, okay. I got something. I think that this code still works. So, I think that this code still works. I don't see it here, but there is a little piece of continuous code um, in the sanity. You know, it's in Python. I have wanted to have a C environment basically, where this should be very easy. So, and you can even do it in 3D, and that would be cool. Yeah, this will be great because yeah, this will be perfect for you. So, just like a simple like agent target, agent has to go to target. When target is hit, new target spawns. In 3D, continuous actions. I think you can put like a little bit of momentum on it as well, like a little bit of acceleration, so it can't just make perfect turns and such. So you have a heading, you go forward, you can turn, in any direction, like up to a specific amount. You can accelerate, you can decelerate, and go to target in 3D. I think that would be like a pretty nice, tiny little project, like 100 to 200 lines of actual C code, like actual logic, excluding boilerplate and stuff. You'll be able to train that super quickly and easily once it's correct. We can put the puffer in as the agent in 3D if we can load in the model. That would be fun. Yeah, I think that there's a lot that can be done there, and we can even make it harder if we want to, because then we can use that to like add walls in for obstacles, and then that'll be similar to what like the drone guys are doing at the moment. Um, yeah, I think that'll be similar to what they're doing. Let me make sure that this. Hold on. Let me make sure it's not identical though, because I think they do have an end with that. Let me make sure it's not identical. Yeah, no, they're doing a ton of additional fancy stuff, I think, here. Are they? Hmm. This is actually fairly similar to what I just said. Shoot. Um, damn it. I mean, it's good that we have so many people building M's, but I have to come up with more ideas. Hmm. Dang, I thought I had something. Yeah, exactly, right? Because, like, I was gonna make a bare bones thing, but they already have a bare bones thing because it's a bare bones drone. They don't have, like, fancy fancy physics for it. So let me see. Hey, there's my there's neural MMO as my thing. Hmm. Mm-hmm. Many have recommended neural MMO. Well, that's cool because it's like 100 times better than it was during my PhD now. So if it was recommended before, it's double, it's giga recommended now. Are any of these good? Okay, I think I know something we can do. Neural MMO? Yeah, have you seen this one? This is Neural MMO 3. Now, this is massive. Runs on the web, the agents run on the web, trained on 2,000 years worth of games, are just like toy little experiment. NPCs, economy, swords and bows, levels, consumables, lots of different tiers of items and armor and equipment, lots of stuff. This agent is the one that we trained. It's playing live in the browser. You can see here it's defeated an enemy, equipped a tool from the enemy, picking up some various different drops and stuff. Yeah. So this is the type of stuff that you can build, right? This is one C file. This is like one C file of brain dead simple code. There's also the MOBA. League of Legends / Dota as an RLM of anybody, but really, really fast. I'm going to give you something that you can make as simple or as complicated as you want. It will be something that I think could be useful, and it will be something that you will be able to do at least the simplest version of rather easily. All right? and it'll be something exciting. So this is this big paper from DeepMind. It's probably one of the top 5 RL results out there. I'm not going to make you implement all this stuff because this would be too much, especially from the get-go. But what you can do, I came up with a cool project for you. Ready? I do hope that you do this actually now because this would be pretty cool for us to have and I think you'd learn a lot. So here's what you do. Right, you make a map. You spawn in some circles with different colors. All right, and then you spawn in some floors. With different colors. And then here is your agent. It can move forward. It can turn. It can turn a certain number of degrees in either direction. So it can move around in continuous space. And it can push these circles. All right? It can push these circles. Now the observation is going to be as follows. This is going to be, in the first lot here, you have C1, which is going to be the color of the object that you need to move. And then this is going to be T1. This is going to be the color of the target that you need to push it onto. And then you have your X, your Y, and then you have X, comma, Y for each object and floor in a consistent order. How's that sound? Doesn't need a physics engine because it's very simple. It's only circle collision, which is just like radius of one minus radius of the other. It's not going to be hard to make fast because you have a small fixed number of objects like this. Every single reset, it's very easy to generate a new task. So this is mini version of Xland. And if you want to go further with this from here, you can go all the way up to Xland or anywhere in between. At the high end, you would produce something of tremendous, tremendous value to open source reinforcement learning into the field. And even if you just do this, this will be a nice little task-based benchmark. Yep, move blob, not towards their corresponding colors. You can randomly generate this every time. So just like every time you reset the environment, just color equals, rand %3 or whatever, target equals rand %3. So essentially what this is telling the agent is move the blue blob onto the red target. And if it does that, it gets a reward of 1. Make nice little small maps and try that. I'm going to put this, you're on the Discord, right? This is a good one, right? It took me a while to come up with one, but this, I think I got you a very, very good one. I think that this will work great. This will be very useful for us because it is a task-based end, right? It's task conditional. You have to rely on the ops to tell you what to do. There you go. Good. Mission accomplished. I'm gonna use the restroom and then I will continue double checking my code here for like 20 minutes and then I will go break for dinner. Be right back. Yeah. Let's finish this real quick. Today was a good day. Today was a very good day. Well, we'll see the results of some of the stuff I did today still. But I'm hoping we did some good stuff. This looks good. This looks very good. Unnormalized nearest Pareto score. Why is this a thing? Normalized nearest Pareto score, yada yada yada. Oh, because I want it in normalized space. Duh. Okay. But why do we want untransformed? That's kind of weird. Wait, unnormalized, untrained. What the hell? Where is this? Unnormalized nearest Pareto score. That's just YT Pareto, right? UPYT. As nearest Pareto YT. Okay, cool. So let's see if we can get this thing working now. Of course. Oops. Axis and NumPy. Forge had to be smart and label it dim. That was rather dim, wasn't it? Oh hum. Burrito. Just burrito. That look degraded? Or is it just this one point making it look weird? Let's see. We'll get another sample just to confirm. Does look a little degraded. Oh, it's also went out to 60. Interesting. Okay, but this looks like particularly perfect, right? So we should probably check again for mistakes. Give it like 10 minutes. You hear your maxes. Normed. And normalized towards min score. Let's just real quick. These should be, right? Argmax. Oh, actually, that's a good point. You can be flipped. No. These are fine. So this portion at the bottom, I think I did a little different, right? Oh, I left in the plus variance here. Wait, but this is only for conservative, so we don't care. I didn't leave it in elsewhere, so we're good. Normalized cores. And the norm is what? Just divide, yeah. So this is... Where is this thing? Pareto Y. Oh, well, this is wrong. GP. Right there is completely freaking wrong. So that's probably it right there. Do I use this? Yeah. Pareto Y is just Y. See. See if this produces the curve real quick. Obviously, we're going to want to do a full comparison, but if I can just get the curve back. In the meantime. There we go, perfect. Now fits with the other one, right? About 50 at 1. Yeah, just rescaled a little different, but about a 1, right about 1. Yeah, it's about the same. Well, maybe it's a little bit under. It did get like a 9.9 in there, that's okay. We will test this. Temple. Just Okay, I think this is it. Try this. Almost there. I just want to get this sweep ready. We'll be set. Hope this is running. Okay. Well, we will see how this does. Oh, I think I forgot. Come on. Yeah, this should be. Try this at least. Oh man. I don't know. I gotta go get dinner. We will see if we can get something set up on this tonight, though. I will be back later. May or may not stream. We'll see. But this is very, very good progress on all of this. So there's a couple folks still watching. Puffer, all my stuff's on puffer.ai. Start the repo to help me out. It's free. Join the Discord, and you can follow me on X for